Today, we're diving into a fundamental shift in cybersecurity. Seriously, the rules of engagement have been completely rewritten, and it's all because of one technology, artificial intelligence. So let's break down what this actually means for the future of digital defense.
Look, if you've ever worked in digital forensics or incident response, you know this scene all too well. It's 3 in the morning, an alert just shattered your sleep, and now you're staring down a mountain of logs. You're in a dead sprint against an invisible enemy, and every single manual command, every grep, every little script you have to whip up from scratch, it's all costing you precious, precious time. This has been the reality for years, but here's the thing. The threat you're racing against, it isn't human anymore.
That's right, because while we've been busy perfecting our manual tools, a whole new breed of attacker has shown up on the scene. One that doesn't need sleep, never gets tired, and operates at a speed and scale that is just, well, it's not human. The game hasn't just changed, it has been completely rewritten from the ground up.
80 to 90%. Let that sink in for a second. That's how much of an attack an AI agent was able to execute on its own in a recent major espionage campaign. And this isn't some hypothetical what-if scenario. This is the new benchmark, and it's all documented in a groundbreaking report from Anthropic. Okay, so let's get into the specifics. The campaign was codenamed GTG1002, and it was attributed to a Chinese state-sponsored group. They went after about 30 high-value targets. We're talking tech companies, financial institutions, you name it. But here's the absolute crucial point. The AI wasn't just a research assistant giving tips, it was the operator. It was the one in the driver's seat, executing the attack and sending requests at a rate that no human team could ever hope to match.
So how does this actually work, right? How do you take an AI and turn it into an autonomous hacking agent? Let's pull back the curtain and look at the architecture of this brand new threat. Here's the command structure. Think of it like a military operation. At the very top, you've got the human operators. They're the generals setting the overall strategy. They point an AI orchestrator at a target and give it the high-level goals. That orchestrator then acts like a field commander, breaking the mission into smaller tasks and delegating them to a whole swarm of AI agents. These agents are the soldiers on the digital front lines, running the scans, testing the exploits, and probing the targets. And boy, are they efficient. In the recon phase, these AI agents just map out the entire network on their own. If they spot a weakness, they move straight to exploitation, where they research and write custom exploit code in as little as 1 to 4 hours. Insane. Once they're in, they start moving laterally, testing stolen credentials to see just how deep they can get. And finally, when they find the good stuff, they don't just dump it all out. They autonomously parse, analyze, and categorize the data by intelligence value before sending it back. The human operator, they only have to step in for a few key decisions.
So this all leads us to a pretty stark realization. You simply cannot fight a machine-speed attack with a human-speed defense. Typing commands into a terminal, no matter how fast or skilled you are, is like bringing a knife to a drone fight. It just won't work. The defense needs an upgrade, a radical one. And this is where Protocol SIFT comes in. Now, this is not just another chatbot slapped onto a tool. It's a deep, strategic integration of 2 really key things. First, the Model Context Protocol, or MCP, which is basically a universal language that lets AI models talk to other software tools. And second, the SANS SIFT workstation, which is this legendary collection of the best digital forensics tools. Put them together, and you transform the analyst workstation into an AI-augmented cockpit.
This is a fundamental change in the role of the analyst. On the left, you've got the old way, the analyst as a tool user. You have to remember the exact syntax for hundreds of different tools, all their weird flags, and you can really only do one thing at a time. But on the right, you have the new way, the analyst as a tool orchestrator. You just state your high-level goal in plain English, and the AI figures out which tools to chain together to get it done, running multiple analyses at once at machine speed.
And this shift, from worrying about syntax to focusing on intent, is the absolute core of this revolution. It's about elevating the human analyst to focus on what we do best, asking the right questions, thinking critically, while the machine handles all the tedious mechanical stuff.
So what does this actually look like in practice? Well, imagine typing this simple command into your terminal. Build a timeline for Jan 10 and find persistence. Notice, that's not a specific command for a specific tool. It's a statement of intent. It's the question you really want answered.
And here's the magic. The AI, living right inside that SIFT environment, translates your intent into a complex workflow. It just knows that to do this, it first needs to run log to timeline to pull all the timestamps from the system into one massive super timeline. Then it has to use piece sort to filter that timeline for the specific date you asked for. And finally, to find persistence, it knows it needs to run RECMD to check the Windows registry for sneaky startup entries. It does all of this in the right order without you ever having to remember a single command flag. It's incredible.
Now, this is obviously incredibly powerful, but it also raises a really critical question, right? In a field like digital forensics, where the integrity of your evidence is everything, can you actually trust an AI to do the right thing? This is where the protocol part of Protocol SIFT becomes so important.
Because this is the question on everybody's mind. It's the one we should all be asking. If an AI can hallucinate, if it can make mistakes, how can we possibly rely on it in a forensic investigation where just one tiny error could completely compromise an entire case?
Well, the answer is that trust is literally engineered into the system through layers of control. First up is something called inference constraint. The protocol itself limits the AI's freedom to just make stuff up. It can't hallucinate evidence. Second, there's always a human in the loop. The AI has to ask you for permission before it runs critical commands, keeping the analyst in full control. And maybe most importantly, the AI isn't creating the evidence. It's just directing the forensically sound, deterministic, and court-vetted SIFT tools that analysts have been trusting for years. The tool generates the verifiable fact, not the AI.
So it all boils down to this. As Anthropic concluded in their big report on that GTG 102 campaign, we need AI on the defense to counter AI on the offense. It's really that simple. It's about matching machine speed with machine speed and matching scale with scale.
And this leaves us with a pretty provocative final thought. We are stepping into an era where human defenders are the orchestrators of autonomous AI agents fighting battles against autonomous AI attackers. So is this the future of cybersecurity? A war fought at the speed of light in the circuits of machines, with humans as the generals just drawing the battle plans? That's a question we're all going to have to answer, and soon.